Welcome back, guys. Today we'll be doing a trigonometry question where we're going to show that cos 2 theta is equal to 1 minus tan squared theta over 1 plus tan squared theta. Also, we're going to show that tan 67.5 degrees is equal to 1 plus root 2. Today we'll be doing a trigonometry question where we're going to do a proof. Prove that cos 2 theta is equal to 1 minus tan squared theta all over 1 plus tan squared theta. Now, what I'm going to do, I'm going to prove that the right-hand side is equal to the left-hand side. Let's look at the numerator. So for the numerator, I have 1 minus tan squared theta. Tan theta is the same as sine theta over cos theta. So that means if I square the tan, then I will square the sine and the cos. So tan squared theta is equal to sine squared theta over cos squared theta. Now I'm going to replace here. So I have 1 minus, this is sine squared theta over cos squared theta. Now, what am I going to do? I am going to find the LCM, where I put 1 over 1. The LCM for 1 and cos squared theta will be cos squared theta then I will say 1 into cos squared theta gives me cos squared theta, then multiply by 1 in the numerator. So I will have cos squared theta. Then minus cos squared theta into itself gives me 1, and 1 times sine squared theta, that gives me sine squared theta. Now let's look at the denominator. Now for the denominator, we have 1 plus tan squared theta. So I have 1 plus, just as before, I'm going to replace tan squared theta as sine squared theta over cos squared theta. Then I will be finding the LCM, so I will put 1 over 1, and the LCM for 1 and cos squared theta is cos squared theta. Now 1 into cos squared theta, that gives me cos squared theta. Cos squared times 1, that's cos squared theta, plus cos squared theta into itself goes 1 times, and 1 times sine squared theta gives me sine squared theta. No, cos squared theta plus sine squared theta is an identity. That is the same as 1. So I have 1 over cos squared theta. Now let's join this together. Now remember, we have 1 minus tan squared theta on the right all over 1 plus tan squared theta. That's what we have. Now replacing the numerator, for the numerator I have cos squared theta minus sine squared theta all over cos squared theta divided by, in the denominator, I have 1 over cos squared theta. Now this line means divide. So that means I can rewrite this as cos squared theta minus sine squared theta over cos squared theta divided by 1 over cos squared theta. Now division, I will change it to multiplication, then I'll reciprocate this, meaning I'll flip this. So what I have here is cos square theta minus sine square theta all over cos square theta multiplication, then I flip this, so I'll have cos square theta over 1. Now this will cancel, and I'm left with cos square theta minus sine square theta. Now, if you have an identity sheet, you can look at it and you'll see that cos square theta minus sine square theta is the identity for cos 2 theta. Therefore, proven. Hence, show without the use of calculator that tan 67.5 plus is equal to 1 plus root 2. Now, from the previous activity that I did, we know that cos 2 theta is equal to 1 minus tan square theta over 1 plus tan square theta. Now, 67.5 is the same thing as 135 over 2. So I can say theta is equal to 135 over 2. So I will have cos 2 theta and I replace theta. So I will have cos 2 135 over 2, which is equal to 1 minus, now for theta, remember I said theta is 135 over 2. So I'm just going to replace theta, which is 67.5. So I will have tan square 67.5, which is the same thing as 135 over 2 over 1 plus tan square 67.5. So all I did, rewrite 167.5 as 135 over 2 degrees. Replacing this theta, so theta is 67.5, or I can have it as 135 over 2, and then here I rewrite this, instead of writing 135 over 2, I write it as 67.5 degrees in both positions for theta. Here I'm going to cancel 2 into 2, goes 1 times. So what I have here is just cos 135 is equal to 1 minus tan square 67. You can write 0.5, 67.5, or 67.5 degrees all over 1 plus, I'm going to put a little curve on my t, so tan square 67 and a half degrees. Now, where I have cos 135 degrees, it's the same as minus 1 over root 2. So I'm going to replace this as minus 1 over root 2 is equal to 1 minus tan square 67 and a half degrees all over 1 plus tan square 67 and a half degrees. So I'm going to cross multiply. So what I'll do is multiply minus 1 times 1 plus tan squared 67 and a half and root 2 times 1 minus tan squared 67 and a half. So I'll have minus, so minus 1 times 1, that's minus 1, and minus 1 times tan squared 67 and a half will be minus tan square 67 and a half degrees. On the next side, I'm going to multiply root 2 times 1, that's root 2. And then root 2 times minus tan square 67 and a half degrees, I'll have minus root 2 tan square 67 and a half. Now, what I'm going to do next, I'm going to carry the minus root 2 over the equal sign, and then the minus 1 will be carried over to my right. So I will have minus tan square 67 and a half degrees plus root 2 tan square 67 and a half degrees is equal to root 2 plus 1. Carried over this over the equal sign, so it becomes positive, so that's why I have positive, and the minus 1 over the equal sign, so it becomes positive. Now this is common, so what I will do, so I'll factor out tan square 67 and a half degrees. So I will have minus 1 plus root 2 is equal to root 2 plus 1. Now I'm going to divide both sides by minus 1 plus root 2. This cancels, so I have tan square 67 and a half is equal to root 2 plus 1 all over minus 1 plus root 2. Now, right here, we need to rationalize. The conjugate of the denominator is minus 1 minus root 2. So multiply the numerator and the denominator by the conjugate of this. So multiplying this, so we're still calculating what is tan square 67 and a half. Now in my numerator, multiplying root 2 times minus 1, that's minus root 2. Then root 2 times root 2, that will be 2, and the sign will change it to minus 2. Then 1 times minus 1, that's minus 1. And then 1 times minus root 2, that's minus root 2. Now in the denominator, we're going to have negative 1 times negative 1, that's positive 1. Negative 1 times minus root 2, that's positive root 2. Positive root 2 times minus 1, that's minus root 2. Positive root 2 times minus root 2, that will be minus 2, because root 2 times root 2 will be 2. Within the center in my denominator, these cancel. So let us simplify what I have here. So I have tan square 67.5 degrees is equal to, let's work out this first, minus 2 minus 1, that's minus 3, minus root 2 and minus root 2 is like saying negative 1 minus 1 is minus 2. So I have my minus 2 root 2. Go ahead and say 1 minus 2, that's negative 1. So we're going to have a change in sign. So this will be positive 3 plus 2 root 2. Now, because there's a square, we have to square root. So let's square root. So we have tan square 67.5 degrees is equal to 3 plus 2 root 2. Now to get rid of the square, we square root both sides. So the square root cancels the square. So we have tan 67.5 degrees is equal to, now square root is the same thing as having the power a half. So this is 3 plus 2 root 2 raised to the half. Now 3 plus 2 root 2 is actually 1 plus root 2 times 1 plus root 2. Now we can test to see if it's true, because 1 times 1 will be 1, and 1 times root 2, that will be root 2, and root 2 times 1, that's root 2, and root 2 times root 2 is the same thing as 2, and then we'd have 1 plus 2, that is 3 plus 2 root 2. So 3 plus 2 root 2 is the same thing as 1 plus root 2 times 1 plus root 2. So in other words, I can replace the center as 1 plus root 2 all square raised to the half. I repeat, 3 plus 2 root 2, it's coming from 1 plus root 2 times 1 plus root 2. If you multiply this, you will end up with the 3 plus 2 root 2. So this product is the same as rewriting it as 1 plus root 2 all square, and then the square cancels the half. So what we're left with is just tan 67.5 degrees is the same thing as 1 plus root 2. And that's it. Proven. Thanks for watching, guys. Don't forget to like and subscribe to my channel. Have a great day.